Hey everybody, my name is Chris and I'm a tutor here at Chegg.com. I mostly do math and a little bit of computer science, and in this video we're going to do an example of an integral using the Cauchy Integral Formula. So this is something from complex analysis. So here we want to evaluate the integral of dz over z times z squared minus 4 times e to the z, and the integral is taken over basically the boundary of the unit disk centered at the origin. It's taken over all the z such that the modulus of z equals 1. So if we were to plot what that looked like, that would be, here's the x-axis, here's the y-axis, and then where z equals 1, that's everything on the boundary of this disk here. Okay, so we'll just pretend that that's a nicely drawn unit disk. Okay, so everything on the boundary here is what we're integrating over. Now, how do we use the Cauchy integral formula? Well, the Cauchy integral formula says that f of z equals 1 over 2 pi I times the integral over the boundary of a domain D. So this is just fancy notation that means the boundary of D. That's all that means. The boundary of a domain D. And let's see if we can get that a little better. Okay, and that's going to be, on the top we have f of w. On the bottom we have w minus z dw. Okay, so as far as the integral is concerned, z is actually a constant, okay? And we're integrating with respect to w. So what we have here then, though it's a little bit different here, we're integrating with respect to z, but that's okay. We want to keep it this way so that we learn to be careful about notation and variables and things like that. Now in our case, and also this formula says that we're going to use this if z is something in D, where D is a domain. Now in our case, what's D? For us, D is the unit disk. So D is the set of all z such that the absolute value of z is strictly less than 1. So D is the unit disk, basically everything inside of here. Okay? And what that means is that the boundary of D is the set of all z such that z equals 1. Okay, so the boundary of D is this red dotted circle here, or in other words, this right here is the boundary of D. Okay? And we want to do this for z in D. Now, in our case, let's go ahead and go to the next page here. We have the integral, the modulus of z equals 1, and what we have is dz on top, and on the bottom we have z times z squared minus 4 times e to the z. So z is actually the same thing as z minus 0. So I'm going to rewrite this as the integral over the modulus of z equals 1 of z minus 0 times z squared minus 4 times e to the z. And then let me write this as 1 and then a dz over here. Okay. So now this doesn't really look exactly like this form here. Okay, but what we want to do then is let's go ahead and rewrite the integral that we have over here. Okay, we're going to want to rewrite this a little bit so that we can actually get that in this exact form here, right? And that's, first of all, that's why I wrote the z minus 0 over here first. And what that's actually going to give us is that all this other stuff, the 1, the z squared minus 4, and the e to the z, that's going to be our f of z. Okay? So then what we're actually going to get is the integral, whoops, for modulus z equals 1 of 1 over z squared minus 4 times e to the z, all divided by z minus 0, and then dz. Okay? So now it's actually pretty much exactly in this form, just without the 2 pi I over here. So here, this right here, this is our boundary, okay? And then our w, so remember, in our integral, we actually have dz instead of dw, so think of these as their roles being swapped. And again, we want to do that just to make sure that we learn how to keep notation straight. So the variable in the integral here is w, and this one it's z. So here, that minus 0 over here is going to, or sorry, that minus z over here is our minus 0 right here. Okay, and notice that here z and here z. So this is actually going to equal Oh, and also this, all of up here, we already said that, but we'll just say it again. This is our f of z. Okay. Now we know that all this stuff equals not quite f of 0. I mean, yeah, there will be an f of 0 because 0, 0, right? Just like over here we have z and z. But what about the 2 pi I? Well, multiply both sides of this by 2 pi I, and we get 2 pi I over here, and then nothing over here, right? Just 1 over there. So this integral actually equals 2 pi I times f of 0, where f of z is given by this. Okay? So basically all we did was we took this integral and we rewrote everything in a form that matches the Cauchy integral formula here. Okay? So that's all that's happening there. Now all we have to do then is evaluate f of 0. So this is 2 pi I times f of 0. And again, this is f of z. So what's f of 0? Well, it's going to be 1 over 0 squared minus 4 times e to the 0. Well, e to the 0 is just 1, and then 0 squared minus 4 is negative 4, so this is 2 pi I divided by negative 4, which is negative pi I over 2. All right, and that's our final answer. So this has been an example of using the Cauchy integral formula to evaluate an integral in complex analysis. So I hope you found this video helpful, and thank you for watching.